Fractions represent pieces or a part of something. In a picture, we can display this by taking a full shape like a circle and splitting it up into equal parts. You can choose how many parts you want to split it up into. In this case, we're looking at 4. So if we cut the circle into 4 equal pieces, we'll have 4 out of 4, or still the whole one. In the orange diagram in the corner, you can see you can then start looking at taking pieces of the whole. For example, you can take 1/4 away and leave 3/4. 1/4 you take away, and then 3/4 you leave behind. When representing a fraction, you always need two numbers. You need a top and a bottom. Technically, the top is called the numerator, and the bottom is called the denominator. However, in most math classes, if you just talk about the top and the bottom, people won't usually correct you. So here you can see an example of 1/2. We've got a circle cut in half. And then in purple, we have 10/15. So we have 10 purple parts out of 15 total pieces. A fraction also represents a division. The notation for a fraction also represents a division, because a fraction and division actually works the same way. So anytime you see one number over top of the other, you can actually replace it with any of the following kinds of notation. You could have 3 divided by 5 using the line with 2 dots in the top and bottom. You could have 3 divided by 5 using the long division notation. You could have 3/5 but written with just a slash. And you can have the notation we were using of 3 divided by 5, 3/5. These are all different notations for division, and you should try to get comfortable with all of them. Now, whenever you have a fraction, you must have equal parts. You cannot have someone's half being bigger than the other person's half. You also don't have to use circles as the only shape. You could use rectangles, you could use triangles, you could use a square. Anything will work as long as you subdivide it into equal pieces. You can use fractions to represent parts of anything. What we'll see later is that fraction notation can also be used to describe a ratio. Let's take a look at this example. Let's say in total we have 9 pets, but those 9 pets are made up of 3 dogs, 4 cats, and 2 pigs. You could then have these 3 fractions. 3 dogs out of 9 pets, 4/9, 4 cats out of 9 pets, or 2 pigs out of 9 pets. You could also have a test example where you wrote a test and you answered 16 of the 20 questions correctly, so your overall grade of the test is 16 out of 20, or 16/20. Or you could convert this to a percent, which we'll see in a later unit. Now there's a few different kinds of fractions. Even though these different definitions do exist, you don't have to let that scare you, because once we start doing the math, all of these different fractions will behave in the same way. So we do have a zero fraction. A zero fraction is the first example, and that's when the numerator, or the top, is 0. If the numerator is 0, then the fraction always represents 0, no matter what the denominator is, unless you have 0 as both the numerator and the denominator. Then that's technically undefined, and something you would cover in a later math course. The next one is proper fractions. So a fraction is supposed to represent part of a whole, and that's why this is the proper fraction, when the numerator, the top, is smaller than the bottom, the denominator. Any fraction like that will always be a proper fraction, and it's smaller than 1. Next is a whole fraction. When the number in the top, or the numerator, is equal to the number in the bottom, or the denominator, then that is a whole fraction, because whenever you divide something by itself, you get 1, and you have the whole part back. And lastly, we have an improper fraction. Sometimes the numerator, or the top, is bigger than the bottom, and that fraction represents something bigger than 1. So if you have 7/5, for example, you actually have 1 whole piece plus 2 pieces more in the next whole. With those definitions in mind, we can place each of these kinds of fractions on the number line. Maybe this illustration will help make these definitions more clear. First, we have the zero fraction. So on the left of the number line, without getting into the negatives, we see the zero fraction right at 0. Next is a proper fraction. Anytime you have a fraction that is part of the whole, just like the original definition, that is where you have a proper fraction. Then right at the 1, you have the whole fraction. So if the top is equal to the bottom, then you have the whole piece. Lastly, improper fractions are anywhere greater than 1. So anytime you have a larger numerator than denominator, you have an improper fraction. And as you can see, going from left to right, a zero fraction is less than a proper fraction, which then is less than a whole fraction, and those are all less than an improper fraction.